that walks you through the lab itself. If you have a big screen, then this is enough real estate to do the work. If you don't have a big screen, then this real estate might be a little bit small. So I'm going to switch screens to get real estate for you, but I wanted to explain the panes and where the information is that you're going to need. In any event, as you scroll down the lab guide, it's going to tell you that the solution architecture here is that there will be Azure Data Lake blob stores, or blobs that are put into the Data Lake store. In exercise 1, we're going to explore this data. And then in exercise 2, we're going to build a pipeline that moves us in the SQL pool. In exercise 3, we'll do a Power BI integration. In exercise 4, we'll experience some high performance SQL analytics with the SQL pool. Then exercise 5 is optional because it may or may not be working. It's mostly a read exercise that you can work through. And often I'll do exercise 4 before I do exercise 3. I find these minutes are about half the amount of time that are necessary unless you just happen to know where all the buttons are. And several of these exercises have a couple minutes where you have to wait for steps to finish. So I wouldn't be frustrated if you find your time per exercise is roughly twice the time they've allotted here, which does make that 4-hour timer a bit tight. The other thing that you should know is you don't have to screen scrape or grab or pull the content from this exercise pane over here, except for the environmental details, the virtual machine, and in your lab validation, you want to be able to prove. If you're just looking for the content of these labs, then they're available in GitHub, and I can share the link with you to the GitHub content that is the exercise scripts. So don't spend your valuable lab time trying to cut and paste examples out of the scripts they've given you. I'm happy to give you this URL. Matter of fact, I'll just post it right in the chat. So that you could go out and reference that outside of the timer at any time you want. Which also means if you want to do the read along on exercise 5 and you've run out of your timer, you can go out to GitHub and do that. So these numbers at the bottom will launch you straight into the exercises. If you want that exercise pane on the right side of the window, if you're happier, again, using a GitHub and you have a second monitor perhaps, you can pull GitHub on the other monitor and then log into Azure separately and use Synapse Studio there, which is what I will do shortly. So with that in mind, the other things that are interesting to you is the environment details. So these are environments that have been set up specifically for you. And in order to log on to different pieces, you'll need these credentials. Here's your unique user for the next 3.5, 4 hours and the password that goes with that user. If you were to log on to the Azure portal, here is the Databricks Workspace value URL. Here is the unique IDs that you'll need to paste in when we go out there. And I'll show you how to go grab these as we get to those sections. Virtual machine is a virtual machine that you see on your left right here on the left pane running, and it'll show that it's running. And if you needed to, you could start, stop, restart it if something gets stuck. You shouldn't need to do anything with that. Occasionally, I'll connect to the virtual machine separately from this window using a remote desktop, but shouldn't be necessary. Then as you go through the labs, as you get to checkpoints where you've accomplished things, you can validate these steps, and the statuses of these will change to show that you've completed various steps. So if you have to show someone progress against this, here would be an opportunity to get validation that you've successfully completed those pieces. They're actively watching whether you've made certain changes in the environments. With that in mind, I have joined onto the Azure portal via a private browser as these users, and I'm going to start walking through exercise 1. We're going to explore the data lake with Azure Synapse serverless SQL pool, and then with Azure Synapse Spark. Again, I came in separately so that I'd have a wider real estate to work with, because you run out of real estate in that little small pane, and it makes it harder for me to demo it and share it with you guys. So with that in mind, we're going to understand data through data exploration. That's one of the core challenges we face as data engineers and data scientists. Depending on the underlying structure and the requirements, different processing engines will offer different degrees of performance, complexity, and flexibility. We can either use the SQL serverless engine in Synapse Analytics, or the big data Spark engine, or both. In this exercise, we're going to perform the exercise once, task 1, exploring data lake with SQL Synapse serverless SQL pool, and then we're going to do the same thing with the data lake Azure Synapse Spark. So you're doing the same thing. You're using 2 different engines and 2 different language variants to accomplish that. So first, we're going to use the UI to explore the data lake with the serverless SQL pool. So first, go to your resource groups. All right, we're going to go into the Synapse resource group. And within that Synapse resource group, we're going to go over to the SQL pool. So before we can use the SQL pool, we're going to have to start it. You'll notice that it's paused right now. When you pause the SQL pool, it's not charging you any money for that compute. So if you're not using it, it's your best interest to pause your SQL pools, because they become rather expensive, especially at scale. In this case, we've got a DW200C, which is one of the lower provisioning performance levels. You push this up into the thousands of DWs, data warehouse units, if you had a real large scalability, high concurrent environment you needed. So we're going to resume this. If you haven't already resumed it, you'll get a UI that this is starting the SQL pool, and this will change to running, and this UI goes away once it's become started. So while that's starting, we're going to move on to the Synapse Analytics Workspace, and if this is a problem, we'll jump back to it. So let me go back to the resource group, to Synapse Analytics. And then we're going to go into the workspace. So you see the hexagon with the DNA squiggle in it. That's the workspace we're going to go into. From within the workspace, we have 2 options to kick off Synapse Studio. Remember, in the overview, we talked about Synapse Studio being the overall UI engine that ties it all together. We can either click on this web link and go there. And a matter of fact, you can cut and paste it into other things so you can navigate there easier, or you can open Synapse Studio from this link right here. Scroll down a little bit, we'll see that within Azure Synapse right now, we've got a Spark pool dedicated in a small size. We've got a SQL pool dedicated, the one we just started, in a DW200, and we've got the built-in serverless auto size pool. This is the one that you pay by terabyte and is kind of a shared infrastructure environment, if you will. It's not dedicated to you. So let's start the Synapse Studio. You'll notice I got another window, so everything is still back here in Azure, and my new window on Azure Synapse Analytics popped up. All right, as it's cloud, everything changes every couple of months. In this case, as we get into the workspace, we need to give it our Active Directory and our subscription and the workspace name that we want to navigate to, so that you could be running separate workspaces from within the same studio. So when we pull the drop down for workspace name, we only had the one name. We're going to continue into that one. All right, so the first time you go in here, it doesn't have anything in the recently used or recent resources because it's the first time you're in. In this case, we're going to go straight into the data. So you'll see you can break out the expand here and get names for it. This is the home page, data pane, develop pane, integrate pane, monitor, and manage, as we talked about in the overview. If you don't want to using so much real estate, you can collapse that and just use the icons. And when you hover over, you get the name of them if you need to get a reminder. So we're going to go to data. So we're in the data pane right now. Within this data pane, we're going to go to databases. Okay, wait, we're going to link service first. Sorry. We're going to link service, and we're going to go to Azure Data Lake Gen 2. And then we're going to expand the stored account under the, this is where I like the added width. All right, so we're going to go to this primary workspace up here, and then the WII, which will give us this Storage Explorer-like view of the files that we have to work with. In this case, we're going to get to the Parquet folder. It's what we organize folders to have CSV data and Parquet folder. We're going to go to the Parquet data. And from within here, you can see the stratification of the data by year. So they've laid the folder information out year by year by year. We'll dig into 2021, Q1, and then the invoice date key, the 1st of January. And you'll see this is still a folder. If you click right here, following the guide, you will not get the select top 100 rows that you want because it's folder. You can't select those top 100 rows from the folder. However, you go into the folder and you've got the Parquet file. Now we can select these top 100 rows. So we're going to issue a select top 100 row, click write script, and we'll notice that it generates the script for us. It's that IntelliSense where we didn't have to write this code. It wrote it for us. It's going to do open role set. It's going to do a bulk read of that Parquet file. It's going to know it's in the Parquet format. And as we hit run, we need to make sure we're using the built-in connector. Hit run. We get an execution. It's actively going out, that SQL pool, reading that Parquet file, and giving us the results from that Parquet file. The Parquet file is a columnar format table, so it's well structured and organized, and should be a SQL-like experience. Just like other SQL experience, if you wanted to say, well, I didn't really want the top 100 rows. Instead, I was interested in, say, a count star, right? I could do a select count asterisk, and then run this again. And now I see, well, there were 32,876 rows, within this Parquet file. I could also state, well, maybe I want to expand my scope a little bit. And instead of looking at just this one specific Parquet file way down here, I want to use the hierarchical nature of the Gen 2 storage, and I want to read across all the files that belong in Q1. So at this point, let's say I change my bulk path from the explicit file to all the files that were in Q1. Run this again. Oops, I have to star. see if that works better. And you notice it's going to run a little longer in the query execution this time because it's got to read through a bunch more files. So it ran out there and said, all right, in this case, you've got 2,991,716 rows across all the Q1 data from 2012 within the specific folder. Okay. So we're going to go try this a different way. So this is a click write version. We're going to then go through the develop hub and we're going to write some code. So we're up to step 13 of exercise 1, if you're following along. As we go to develop right here, we got the develop pane, and we're going to go to exercise 1, read SQL, read with SQL on demand script. All right, and as you double click on it, it pops it up into this window. So the other one was unnamed because we just did a click write. We've never saved this to a script name. We could, much like SSMS. This one was a script that was in our SQL script library, and we pulled it over. So in this one, again, we're going to adjust this from the SQL pool to the built-in because we've got built-in data. We're going to connect the database to, I'm not quite sure whether we use default or master. So we'll try both. And then we'll run this execution. In this case, we've explicitly said we're going to open up the CSV format record, all the Q1s with this field terminator, with the field quote, and with this explicit schema that's been defined. So we've defined the schema, we defined the delimitator, we've said it's the CSV. See if we can get that to run. So again, one of the key differences is you'll notice the path here is a fact sales CSV, not the fact sales parquet. You can see that if we go back here. Remember, so this is CSV data in a folder. That will the prior one's a parquet folder. One of the advantages of parquet is it's gonna know the schema structure because it's a tabular data. CSV is not gonna know the structure, so we're gonna give it an explicit read. So we're gonna get the same results. 2,991,716. We've done the same thing a different way. In this case, we had to define the schema because it's CSV, and we used a script based on open rule set. And this one, we were click write exploring through the parquet files and then adjusting this bulk path and then perhaps adjusting the SQL statement. So we'll move on to task 2, exploring the data lake with Azure Synapse Spark. So again, if you're following in the labs, we're into exercise 1, task 2, step 1, navigate to the data hub and browse the data lake folder. Again, through the www fact sale parquet. So we can go back to data tab. We're still linked to service. We're going to go to the data lake storage account and look for the WWI and look for the fact sale parquet. And we're going to navigate our way down to that file again, 2012 Q1, January 1st. And we're now in the data lake storage account versus the primary storage account. And we're going to click to new notebook, and we're going to load to data frame. So in the SQL script, we were interacting with the Synapse SQL pool. in the new notebook, we're going to interact with the Spark clusters. So we'll load a data frame. And you'll notice that this one is a notebook, as where these were scripts, and they have the little curly scroll icon. This is a notebook with the little notebook icon. You'll see that the features at the top change. We're going to have to attach to a Spark pool, and we're going to have to pick a default language. In any event, we've loaded to a data frame. We've got a notebook with PySpark code to load that data into the data frame, and then to issue a display for the first 10 rows. You don't have to know Python to be able to read Python. It's pretty easy to understand. So we're going to make sure we're attached to the Spark pool, and then we're going to click Run All. All right, so this is one of the things about the Spark cluster pools. They're very powerful. They can do work very fast. They're highly extensible, expandable. You can scale them up, you can scale them wide, but they charge by the number of minutes or seconds that your cluster is running. So if you're not doing anything, the clusters are not running and they're not provisioned. So the very first time you go to use a cluster and you start up the cluster pool, it takes a couple minutes to get that session to start. So you see this wait for a few minutes while your session starts in this starting Apache session right here. That's only because the cluster wasn't warmed up and running, and it's provisioning that as we speak so it can be used. Generally speaking, if you're in the middle of doing a lot of jobs, you don't want to stop and start, stop and start, stop and start your clusters. You would start them up, do all the work you intend to do, and then tear them down. So we'll wait for this to get started, and then we'll see the output of the 10 rows. We'll then rerun it so you can see how fast it would run if the cluster was already up and going. One of the nice things about the clusters running in Spark is you could have different size clusters for different activities. Let's say you had a really intense workload. It's going to run for a short period of time, and you want to give it a really powerful cluster. Okay, we've switched to running, and we switched to waiting, so that implies that this cluster is up and going. You could also have long, thin, slow activities, which might take a smaller cluster or a smaller number of nodes. So now we've got the job execution progress. We've got 2 executors and 8 cores. That's talking about the cluster size. We'll look at that monitor in a second. And here are those top 10 results that have come out of that notebook display data frame limit 10. So again, very similar to what you experienced in the Spark pool, but instead of going through the SQL engine, we've gone through the Spark engine, and we've started up a cluster or a pool of clusters and used it to pull in that Parquet data from the data lake and make that useful. So we're going to rerun this real quick just so you can see. Let's hit cell 1 to rerun. Run cell. And if you remember, the first one took a couple minutes. We've already got the cluster attached, we're already cluster running, and this is a couple seconds. So the delay you experienced wasn't that the job itself took a long time to run. The job itself ran in 6 seconds. It was the orchestration of setting up the cluster and getting it running and attached to the job. So you can also, because this is a notebook and it's in Spark, it's taking advantage of all these features, do some embedded visualization here. So we've been looking at data in table format. You can also look at chart format. And if for some reason this isn't terribly useful, you can then change the definition of the chart. So in this case, let's change the key to customer key. Let's go to customer key, and let's change the values to city key. Generally speaking, the labels are alphabetically stored out there. We'll keep the count aggregation, and we don't need to go stacked. We'll hit this apply. So it doesn't try to rewrite this every time you hit a new value like Power BI. It waits for you to pick it and then hit apply. So in this case, we've got a count by account of city keys by customer key. So we can see which customer is across the most cities graphically, as opposed to having to figure that out from the data in the table. Right? So if we look in the area just below this notebook, again, we've got one cell right here. We can add code, and that gives us cell 2. So you can put dependent tasks 1 cell to 2 cell to 3 cell to 4 cell and build yourself kind of a package of work to be done. Each cell can have its own language. In this one, the language happens to be PySpark as a definition, but we don't have to use PySpark. So in this cell, if you're following on your lab step 9, I believe, is going to have some code for you to paste in, and we could drop in some code here. If you have templates built, you can do that. You'll notice your data lake name right here is generic and not useful because it's coming out of the script. You can either scroll up here and pull it out of there, or you can go to your workspace lab information here, environment details, and go into your data lake name. Where's the data lake name? Workspace storage account name. All right, so the ASA data lake has that name right there. I'd recommend just pulling that from this string right here. It's quite a bit easier, right? So we'll go there. Obviously, this allows you to cross data lakes as long as you have access and do things from there as well. So we're going to paste in the new data lake name, and then we're going to run this. In this case, the data frame is reading from the CSV. In this case, it was reading from Parquet. And this one, we limited it to 10 in the data frame. This data frame display limit is 100. So we're going to execute this. It is running. And as we've got the succession, and now it brought back the data. And you'll see the scroll bar is quite a bit deeper here because we got much more than 10 records. You could in turn chart it. The difference in the two, this one again, we went through the CSV, and this one we went through the Parquet. So in this exercise, we've experienced how do you click right on a file and look at the data from Parquet. How could you bring in a script and the SQL pool and look at the data from CSV? How would we go through the Spark engine and look at very similar Parquet data using data frames and the Spark read options, PySpark language, perhaps do some charting on it? How would we then take a look at that data in CSV format? So you can see how easy it is to pull in data either explicitly from a specific file or from all the files within a folder structure. using the Synapse Studio interface either against Parquet or CSV, either using the SQL pool or the Spark cluster. So we'll leave these here because they're connected but not actually doing anything right now. So we'll get that Spark session, keep the Spark session attached, and we don't have to start up next time. So instead, normally when you're done, you would close all these items. As soon as you close this, it'll detect, hey, there's no one using the cluster. I should tear it down so that it's not using any money. But we don't want to have to wait for it to start up in exercise 2. So we're going to leave these open in a moment. So that concludes exercise 1. Quick pause for questions. If anyone had questions on how you can explore data lake files, either through SQL pool or the Spark clusters in Synapse Studio, Parquet files, CSV files. All right, if we don't have questions, I'm going to move on to number 2. You may be in number 2 via the lab guide down here. This is building a modern data warehouse with Azure Synapse pipelines. Hang on a second, I got someone calling me. All right, so you may have moved on to exercise 2. I'm going to walk you through it. This time, building a modern data warehouse with Azure. And we're going to use those notebooks and data flows to ingest, transform, and load data. And we're going to modify, explore and modify notebooks. And if you want to do the Builders Challenge, we'll kick through that. We'll explore, modify, running a pipeline, doing a data flow. We're going to monitor the pipelines and then monitor the Spark application so that you can see what's happening under the surfaces. Several times in the scripts, you're going to need to put in your username and your unique ID. And those items are coming, again, from these environment details, your unique ID and your lab, lab VM starts your lab, your ODL username and your password username, the ones they're asking for. These are tied to your Azure assets. These are tied to your VM, which it's already started for you. So again, I'm going to move into a full screen mode. So we've got more real estate to show you what's going on. All right. So in exercise 2, we're going to explore and modify a notebook. So again, we're going to kick into this develop pane here. We're going to add a notebook. Oh, we already have a notebook open, so we just use this notebook. All right, that's why we were saving it. We're still attached to the Spark pool, and we're going to go to add code down here in the bottom, just like we did before. So we're going to paste in from object 4 or step 4 within exercise 2. This is, explain this for a second. This is the string that tells it this cell is running Spark program language and not PySpark or whatever Python, the default language of the notebook is. In this one, we're importing a specific library from the Spark session, and that's going to help us read the sales files. And this other one, we're going to then set the path to the data lake. And you'll notice that it's got the generic name again. So we're going to go grab this again. It's just easier To grab that from there and pull it down here. All right, we'll kick this off. So we're importing the libraries and setting the variable Azure Data Lake storage path that we'll then use later for that into account. The Spark, the percent Spark sets the language to Scala, which is required to use that Spark session library. Okay, so we say it's executed 5 seconds. We've got the import, we've got the path statement. We're going to add some more code down here. And then we're going to pull in another string from the lab guidance. Right, in this one, we're going to load data from the CSV files into data lake into a data set. The options parameter in the read command specify that we're using CSV and that the headers are on, and that we're going to infer schema from the data itself. And we're going to give it separators with a pipe, and we're telling it where to load the file from. The FactSale 2012 Q4 and the variable ADLS path is what we set up here. And we're going to show this frame that we loaded, sales, and then we're going to print that schema that it inferred. So go ahead and kick off cell 4. We're waiting for that. And the show 5 within sales, sales is the name of the data frame we put together. Show is give us the top 5 rows. Job executions in progress. There's more information down here if you want to see it. We're going to look at that a little bit later. So you can keep it hidden. You don't have to look at it. And then here's the results of that read of the data frame. So we've got the various columns that came in, got inferred. We inferred the headers from that first column, and then we've got a structure that it popped out of the schema. We're going to add some more code at the bottom and pull in step 9 if you're following along in the lab. Again, this is Spark code. We're going to import a couple more libraries, the utilities for the constants, the SQL analytics connector, the save mode. Navigating these libraries becomes a big piece of the knowledge work that you'll need to be able to be highly effective in Spark clusters. We're going to set a target variable name. In this case, it'll be the SQL pool ww1 staging.sale. So we're writing a target table. And then we're going to write with a limit of 10,000 rows in append mode to this table name right here that we've set. So this is where we're setting the sink, if you will. If that was the source, this is the sink. We're using Azure Active Directory pass-through, so we don't need to create any password identities, or it's managed by the connector. All right, so let's kick this off. Okay, as this is running at the bottom and the job execution starts, we can take a look at what's happening here. And you'll see that we've got some steps kicking out, and we've got some success. And then we can begin looking at the, you see some additional jobs kicking out here. It's not quite done yet, but it's kicked out job 3, job 13, job 14. These are just ordinal numbers and the jobs that the engine's tracking. And you can watch the stages of them succeed. And in a moment, we're going to be able to go and take a look at the data. Oh, there it is. So it tells us command executed 57 seconds. So we moved over those 10,000 rows in just under a minute. And here's the various stages under the job steps. And we can move into all of these clickable links, or we could look at them a different way. At the moment, we're going to go check the data. So we just loaded it to SQL pool 1 www.staging.sail, and we ought to be able to see that in the data pane now. So we're going to go over to data. Before we do that, we're going to go ahead and close this and discard the changes, because since this is connected, it's keeping this cluster open. And we're going to do something else with the cluster in a minute. And this might use enough of the resources that the other cluster activity doesn't get one on. So we're going to close the notebook. We could save it before we closed it. There's nothing particularly useful here. We're going to discard it. And that'll also deallocate the connection to the cluster. So it's just being tidy and saving our resources so that we can use them for something else. So let's, again, go to that data. And in this case, we weren't linked to the data spaces. Instead, we're going to go to the workspace, and we're going to see our SQL pools. So if you remember, SQL Pool 01 is the dedicated one. SQL On Demand is the non-dedicated one that's per terabyte processing. This is the one we started earlier, and hopefully it's still running. Might be on autopause. Don't think so. So databases, SQL Pool, and then we have tables. And this will look familiar to perhaps SSMS for you. If we expand the tables, we can locate the table named ww1staging.sail right down here. And we click the columns. We can hit the ellipsis and select the top 100 rows. We've been selecting top 100 rows so far. So now this looks just like most of the T-SQL you've experienced before, and it came back in under a second because this is part of that reserved capacity pool that's running for you at a high degree of concurrency. So this is the data that we loaded into the SQL engine from that CSV file that we pulled in, or we could have pulled in via Parquet, again, through that Spark engine. So pretty easy to see that the data got here. Again, we only have 100 rows because we limited it. All right, so we're going to go ahead and close this again, just to tidy up. Again, if you wanted to chart it, we could chart it. We could export results. We could do a bunch of fun things from there. If you get extra lab time and you want to play with it, that might be a neat space to explore. So we're going to discard and close the changes. If you want to take a moment to diverge through the bonus exercise, we can do this via the C# notebook. Shouldn't take too long. Let me run through it to develop real quick. So we go to develop. We go to notebooks, exercise 2 bonus with C#. You'll notice that the language of choice in this one should not be Python, but it should be C#. And the IntelliSense now makes a lot more sense because it's reading it with the context of the right language. We've got the Azure Data Lake path already configured, so there's no generic name here. It looks like we're pretty good. You've seen me running one cell at a time. You could step through them if you wanted to watch each of them, or you can run them all in order from the notebook up there. So in this case, again, we're setting the path. We're setting the read options. In this case, we're inferring the schema. We're picking up the header information. We're telling it it's CSV, and here's the 2012 Q4 data. Going to show 5 records. and we're going to print that that schema out. Then using this system collection, we're going to set up a JDBC connection to Synapse Analytics, and we've got to give it some workspace name. This would be better done with secrets or key vaults than leaving it clear text, but we're not doing anything sensitive here. Set up a target name of a table, and then we're going to write that data that we retrieved into that table. This is doing the same exact thing we just did. It's just doing it in a different language. And again, it took a while to start the clusters, so this isn't taking all that long to run. It was 59 seconds to get this cluster started and set the variable. We've now got the read occurring, right? Inferring schema in the CSV, and we can see all the jobs rolling through. You can see the sub-steps in the jobs. If that's interesting to you, you can click through to get absolute details on those. We'll see that monitor later. We've got the schema, the first couple rows, and now we're seeing it doing the write process. We're at 1 of 9. 8 of 9. Let's see, we've got the last step still working. You can also see the running up here if you don't want to scroll down to each and every cell, but it's not quite finished yet. Okay, I'm gonna take a bet that it'll be done by the time we go look over there, and I'm gonna go look for it in the data pane again. So if you take a look at the table name, we picked WW1 staging sales C# or sales C#. If we go look, if this finishes by the time we get there, we can go into the SQL pool, we go to tables. If we don't see the table, we can click right and refresh. And then you can see this table, WW1 staging .sales C# that we just created. Wasn't there, then we did the refresh, now it's there. Again, click right. New SQL script, select top 100 rows, and then we can see the data that the C# cluster-based program put in there. Did the same activity, we just chose to do it with a different language. All right, so I think we're going to go ahead and close this and then walk into task 2 for this, which is to explore and modify a run pipeline containing a data flow. So we just did the script method of reading data in via Parquet or CSV and then writing it out to the Synapse pool. We're going to go look at the pipeline method using data flows. So, all right, so this is done. We can close this. We can just guard the changes. This is done. We're going to close this to free up that Spark pool, so we're not using any resources, and we don't need this. Well, let's keep this around. That's useful. The data lake string might be handy, and we can get back into data pane pretty quickly if we need to. All right, so we're on to exercise 2, task 2, explore, modify, and run a pipeline containing a data flow. So in Synapse Studio, we're going to find a new entry over here. We've been in data, we've been in develop. We're going to go into integrate from the left-hand menu. And we can see that this specific environment has some pipelines set up. So you can create new pipelines, you can interact with pipelines that exist. We're going to go to exercise 2, enrich data. And then we start to see the activities and the organization for these pipelines. So selecting that pipeline opens at canvas. Again, this is where it's useful to have some more space left to right. You have a code-free graphical interface that gives you an opportunity to put together pipelines to do data engineering, data movement, data orchestration. So we have 2 activities in this one: to enrich the customer data and to import the customer dimension. We're going to take a closer look at each one of those. In the canvas, let's select the copy data activity. And you see when I hit copy data, all this information, the metadata about it pops up. You can move the borders so that it's easier to see bits and pieces. All right, so we're going to take a look at the metadata properties about this copy data activity that's within this data flow. So generally, we've got a name for it. We could change the name if we wanted to. We have a description for it. We've got a timeout, number of retries, intervals for the retries, a source, which tells us where it comes from, the source data set, it's the connector. We've got a file path in that data set we can manage. We can preview data if we do some other bits and pieces. We're also telling it where to sync. In this case, we're syncing it to the staging dim customer, ASA. And we're giving it a unique ID that's a substring of the pipeline run. We're using a bulk insert copy method. I'm getting ahead of myself. In this case, I think we're going to change from bulk insert to polybase. Polybase is opportunity to reference external tables that are in qualified storage formats in the data lake, like ORC and Parquet. And it has the ability to then auto-create and manage dynamic content. So in the mapping, we get to see how did we map source to types, and it'll auto infer some of these if they're identical column names and identical types. If you need to cross column names and types, you can do that explicitly. Again, this is a low code environment. And then under settings, we're going to go ahead and okay, so this is going to tell us about the data integration units during the copy iteration. So there's some compute that's used by this, and it's saying that the copy duration activity is going to charge us 25 cents per DIU hour. So you can learn more by clicking through about what the per DIU charges are, and that is also scalable, and it's also part of the opportunity to make this go faster by paying more, or only pay for that which you need to use. So we're going to go ahead and enable staging, and let's see. In the enable staging, we're going to have to set the staging account link service. Let's see if I can scroll down and get this a little better. Okay, we want data lake 01. You can see it over there. It's hard to see in this UI. And then within the storage path, we're going to say, let's use a staging path, right? Now we could browse for it. And if we want to, yeah, let's enable compression. That way we're effectively using our bandwidth and our storage space. Generally speaking, compression is cheaper because the compute to compress it is less expensive than the I/O and the bandwidth to move it uncompressed. So generally speaking, the way we'd want to manage that. Okay, so we've made some alterations to our copy data to make it a little more effective. We could test connection if we wanted to. Everything's been set up for us. It shouldn't be a big deal. We're going to switch to the mapping data flow, and we're going to work on those settings as well. So in the mapping data flow activity, again, you have the general, it's the name, the description, timeouts, retries. In settings, we've got some pass-through information in this case. You'll see that unique ID is set by this pipeline run. Enrich data parameters, we've got a unique ID set by the pipeline run. If we wanted to use staging, we could also set that up here. In the parameters, we can parameterize this. In this case, we've got a substring of that pipeline run for the first 8 characters to give us a unique ID. All right. Let's see what's next. So we're going to double click into this mapping data flow so we can actually see the substeps that exist within here. So as you double click, it went from this high level view to this detailed explosion view of what's happening inside this data mapping. Typically, we want to enable a debug mode, but it's going to probably take quite a while to get that started. So your lab has some what it looks like if you were to do the debug mode session. I'll talk through them. And that data flow debug kicks up here. But as I mentioned, it's a long enough time to start that I don't think we want to wait just to see that start so that some of these buttons light up. Again, you can manage this UI, you can zoom in, you can zoom out, you can slide things around a little bit, add sources, and then this bottom pane, if you don't have enough real estate, you can slide it up and down. So within that data flow canvas, we're going to look at the construction of the data flow and look at the greater details. So from a high level, the Enrich customer data flow has 2 data sources. You can see those over here, postal code and DIM sources. We're going to ingest that data into the data flow, the Enrich Data and Enrich Data ADLS components on the right are the syncs. So here's where we're going to send it out. Here's where we're going to bring it in. And here's the things that we're going to do in the middle that involve the translations. So let's click into the postal code a little bit. So as we click into postal code, you'll see this bottom pane changed. And we've now got all this metadata about this source setup. So in this case, we'll notice that the data set is that external postal code in Azure Data Lake storage. So again, we didn't have to have it in the database as long as the connection is defined and we understand the source. We just bring in that data set and make it useful. If we select the projections tab, I'll walk through the options here. Projections tab, we can then look at things like the type of format that's going to happen as we push this out into the other one. You'll notice in this case, zip code is a string. Certainly you can make a zip code an integer. but in doing so, you will strip off leading zeros. Zip code might be alphanumeric in Canada and other things. Often zip code will leave a string even though it looks like a number because we don't want it to try to do math on that column. It's more of a descriptor than it is a numeric value. So we'll leave it as a string. All right, data preview would let us bring the data in. We'd have to have debug mode on to do that. If you're following on lab step 15, data preview would then run out to the source and pull some data in and give you the opportunity to take a look at that. But I didn't turn on because we're going to try and move a little faster here. Before looking at that postal code filter, let's select the plus on the first button to the right of postal codes. We're going to reach right there. So let's go back to projection. Click on this plus. So we have an available list of transformations that we can do on here. And again, much like Data Factory, we could create a new branch, a fork in the data. We could join in data. We could conditionally split it. We could look up an enrichment value. We can modify the schema. We can do aggregation or create a surrogate key. We can even pivot or unpivot the data if it's let's say it's lined up as a key value pair, or you want to transfer it to a key value pair. You could do those pivots and unpivots here. So roll up and down. Again, you can filters, you can do sorts, you can do all sorts of different mapping flow transformations. And there's a link within the lab for how do you manage those data flow transformations. So let's go to the postal code transformation itself again, and we'll look at the filter settings. As in here, we can see the definition is that there's a SQL where clause string that you can see and greater or equal to integer zip 9,000 and lesser than equal to integer zip, I say 90,000, 98,000. So we're putting a range of values on the zip, and we're going to then exclude some of the junk that's above or beyond that. So this might be an example of a data quality step that you're doing. Right. So if we click on that, we'll get into the visual expression. So you see how quick that dragged us into here, forward and back. And if I wanted to, I could change this. And I could add expression values. I could add functions. This is kind of the way that you interact with a SQL code within there to do fine tuning. And if you were done, you'd save and finish it, and it would then put this into the bundle. But we're not going to make any changes at this moment. We'll cancel this. Currently, we're saying that all zip codes must be between 1 and 98,000. Let's get to the dim customer. Got the projection again. We can allow schema drift. This is an interesting feature. So schema drift is when your source data is going to collect perhaps new columns or new data elements, and you want to allow the data flow to be tolerant of that and optionally even pass it through. If you don't allow it, you're assuming your schema is static. If you're going to allow it, you're assuming that there will be an evolution of the schema and you're accepting that the schema will evolve, and that shouldn't stop the data flow. You can also infer drifted column types. Let's assume a new column shows up. You can be explicit in stating that you want it to be a specific column type, or you can infer what the column type is. You can also validate the schema matches a fixed data contract if you wish. Jump into projections. Okay, so we've got a schema that we've had inferred and brought in projection types. And let's go to join postal code. Let's ensure the join settings tab is selected to see how you can join the data sets using a graphical interface. So in this case, join settings says we want to do an inner join. If you're an old SQL Pro, inner joins, full outer joins, left outer, right outer, cross joins, Cartesians, or all options and how you put it together. This is just letting you know what join condition you want to place on it and which columns it are that you're trying to join from the left to the right, and whether this is equality or inequality. So you don't have to have a lot of SQL skill, you do have to understand the concept in order for that to work. So moving over to the next transformation, select our desired columns. You'll see that, let's scroll this down. We picked up both of these, right? Not just the one, but this is a cascade effect that falls out of that activity, and then these go to two different sinks. So within that, let's go through the settings real quick. We can skip duplicates on output columns and input columns. We can manage the output stream and the input stream. And then again, we have the mapping that we're going to do through these, and this will auto populate based on equality on name, and then you can set up explicit mapping if it's different, and the auto mapping button enables some of that items. Right. The last two items are the sinks. So let's look at the enriched customer. In this case, we're looking at the sink, the output stream name. This is the stream of data that's moving through the pipe, the flow. And this is the data set that we're going to push it to. Right? And again, we're going to allow Schema Drift in this case because we might want to pick up new columns as they go through. Okay, let's go to the settings tab. Within Optimize, we could do things like adjust the partitioning. We could do a bunch of things that make this a little more scalable and industrial to enterprise. At the moment, it's a little beyond the scope of just a hands-on lab. So let's talk about the things we need to go to get to kick off and watch it. And in this case, we're going to allow insert. If it was a merge statement, we could allow delete or upsert or updates. In this case, if the table does not exist, we're going to allow it to recreate the table. We could do a trunk and replace. If we have pre-scripts, well, maybe there's a logging utility that says, hey, we've entered this step, and here's the event code that we're managing the lineage. We could have post-SQL scripts that we run that say maybe log successful completion or log the number of records that we put in. We could add those there. Okay, so we've got an understanding of what that data flow does. Let's go back to the enriched data flow overall and return to that pipeline. We're gonna have to connect these together. You'll see that they're two separate objects and they're not logically related at this point. So we're going to click on enriched data flow, and there's one more change we have to make. The data flow depends on data written by the copy activity. So we need this dependency to get that unique ID. In the data flow canvas, we're going to select the green box to the right of the copy data, and we're going to drag that to the data mapping flow. So you grab this box, you drag it up there, and that creates this line, this flow. It says you start here and then you execute that. This is the orchestration. All right, at this point, we've made some changes. We're going to go and publish those changes, and then we're going to set up a trigger to execute this and then watch it run. So let's publish these changes. This is part of the built-in, code governance, SDLC. As people make changes, you can go back and see who made the change, when they made the change, when it was deployed, and you have multiple workspaces. So you might have a dev, a QA, and a prod, and you can move from dev to QA and prod. In any event, we'll publish this. Publishing, we're deploying changes in Workspace. The metadata for the flows are adjusting. And we've done published, right? Published successful. Pipeline's ready to run. We're going to add a trigger. So a trigger is how you tell this when you want it to run. So if we were to edit a trigger, we can make it a conditional trigger and say we want you to run at this moment in time. Every Tuesday at 3 o'clock, we could say we want you to run after this other activity successfully completes. At this moment in time, we're just going to trigger it now and say, I just want you to run now. Then we have to OK that. Which means that this should now be running. Exercise 2, running Enrich Data. So we're going to move on to task 3, and we're going to monitor these pipelines and see how those are going. This lab is a little longer than they mentioned the first time. You can click right through it, but you won't learn much. So we're going to monitor. And now we can see exercise 2 is running. We can see it's in progress. We can also see these other things that we did succeeded in when they ran. So all this metadata is stored within the system, and we can pull that out and make it useful. So under the integration, we're going to look for pipeline runs. We're going to select exercise 2. And we'll see this in the data pane, and you'll see that it's in progress. You can see there's a green check here, which says copy data has completed. Whereas data flow is in progress. Right? So for about 5 minutes, it'll auto refresh. If the auto refresh doesn't occur, or it takes longer than 5 minutes, you can hit the refresh button on the canvas bar, this button right here, which refreshes the conditions. And that'll tell you the run start and all the bits and pieces there. So we're gonna go take a little deeper look at Enrich Customer and see if we can catch some of this while it's happening. Let's go look at import customer dimension first, because that's already done, and then we'll come back to the others. So if we look at the output of this, this gives you the metadata as it's stored in the system. This is a JSON format that tells you everything that happened during this output and how it was set up and whether it succeeded or not, when it started and how long it ran, which queue it was in, and any validation reports. So these become very useful for auditing and verification. Another way to view this is to get the details. So as you hit the glasses, so the last time, this is the output JSON. Effectively, this is the input JSON. So this is what went in to the instructions. This is what came out of the instructions, right, within the pipeline. Here are the visible details of the instructions. So within here, we get more detailed activity of that run to include what the duration was, where the start time was, whether polybase was used, durations, number of parallel copies, DIUs that were consumed, and the overall duration and where it went from. It might be interesting to see that it went from east to central to west, which would tell you you're moving things across data centers. Get data written in volume, rows written in quantity, and then an overall throughput record. Again, over time, this becomes very interesting to watch and see it go up or go down. All right, so when this is done, not quite done yet, we're gonna wanna go in and look at that activity run. So all right, so it's a little bit early to go in there. I think we'll do it later, but some of the things you can do is move it from a list to a Gantt chart. So imagine that these run serially, or some of them run in parallel and others run serially, and you wanted to see what was taking up a large portion of your runtime. You can switch over to a Gantt chart, which then tells you what the distribution was for how these ran. And they stacked, and which one graphically was using the large piece of time. And then they're interactive, so you can click on those buttons and get the details of the duration, and you even then get a pipeline run ID that you get into the actual run itself. These are the ones we did via the scripts. I'm going to back out of here. Just wanted to show you that some of that is available. So bring it back to monitor and go back to our list. What we really want to do is see this one finish, so we can dig in here a little deeper and take a look at what happened. You can see that, import customer mention ran first, and now we're waiting on enrich customer, and still blue because it's still running. So still running. So back to all pipeline runs. I'm going to take a moment and move over to the message window and see if anyone has any questions. We're coming up on the end of the second exercise. We'll probably take a short break after this, and then I'll move over to exercise 4, and then we'll go back to exercise 3, assuming that we haven't run out of lab time yet. Okay, I had to poke the refresh button to see that this thing had finished at 6 minutes and 54 seconds. With that in success, we're going to then go get those eyeglasses. And we've got enrich, import customer dimension, enrich customer dimension, and then that was the interesting one that had all the steps. We're going to dig into here. Take a detailed full screen view of that data flow. So if there were failures, these wouldn't be green and check marks. They'd have yellows or reds or oranges and X's in them. We can see the amount of processing time that was spent in these relative activities, the enriched customer data and the enriched customer data ADLS. We can get the number of rows. We can get the number of filtered items. We can get the dim customer dimensions. And this gives us some idea of the lineage of the data as it moves through the pipe. So we're going to select the desired column and look at that transformation step. And this right pane pops up over here. We get the ability to look at details that occurred within that specific component. So we have 400 rows calculated. We have the stage time at 46 seconds, one partition. It's interesting that our last update is invalid. And we can look at another element like the sync. So enrich customer data, we've got the mapped columns, we've got the sources, we've got the targets, the table and the column. We've got the rows calculated, stage time. We could choose to jump in and edit the transformations if we saw something that was wrong and get that rerun. Okay, so when we're done with this inspection, we could also then click this X and get back out of here. The back button will get you out too. As we get back to this page, again, as I was preview showing you, this is the list of actions. There's only 2 in this case, but sometimes these get rather complex. Gantt chart can help you figure out which pieces are graphically ordering, running in which order, which ones have which dependencies, and which ones are taking the largest bit of time. They're also interactive, so you could click on them and get information about their starts, their stops, and then all the metadata that is coming out of the telemetry of that process. So all this information is stored in there, and there's actually, out of the scope for this class, but a new product that Microsoft has come out with called Purview that can read this metadata, and it can put together a lineage of your data and say, you know, this item came from this item, came from that item, and help you walk it forward and backwards. Quite exciting. Right now, it bases the lineage off of reading ADF or Synapse flow logs. So another reason to consider doing it in Flow. Okay, so we're going to monitor Spark applications just so you see. We saw a data flow and we jumped quickly in the Synapse pool, but we're going to go look at what would this look like if we're monitoring Spark. So as we did before in the monitor, we're going to kick in a monitor. In this case, we're going to look, instead of pipeline runs, at the Apache Spark applications. And you'll notice that we've got a couple here that we ran earlier today. You can put some limits on your keyword search. Do you want to find the ones that failed? Do you want to find all of them? Do you want to run the last 24 hours, the last 1 hour, the last 7 days? So we're going to look at the last 24 hours. The environment hasn't been up that long. And we're going to look for all status, and we're going to try and get the successful flow right here. So let's click in to this successful flow. Then again, this is a Spark job that we ran earlier. And you can see, if you remember, it had multiple stages when we dropped down to watch that running. And you can take a look at all the different stages that the job went through. And a matter of fact, there's some playback buttons. Probably have to wait to show you that, but let's get into logs first. So these are diagnostics. Were there any failed jobs? No, it's green. All 4 jobs complete successfully. Was there data skew? No, we didn't detect any skew. That's important because if you send it wide to multiple clusters, if one cluster is overloaded and the other is underloaded, then you often have to wait on the overloaded cluster. So that skew of the data can make a difference. Time skew, a similar situation. Executor utilization. So we weren't particularly efficient on the utilization of our nodes. We were only 43% effective. But again, not production, so probably not all that important to us. Let's look at the logs real quick. So within here, now we can get information on all the different stages of the logging and exactly what it went through in some rather verbose, trace level information, all the way down to the partitions and the physical plans that it chose to put together. And then we can also put limits on the log so we don't have to see so much information. Okay, let's go to one of the specific stages. We'll pick stage 3 and poke view details on this. So you can look at these. Yep, there we are. And now we're going to get into the Spark cluster metadata. So within here, we can look at the summary metrics for completed tasks. We can look at the aggregated metrics. We can look at how many times it had to attempt and what the successes were. This really gives you a low-level detail information of what happened within the Spark cluster itself. We just gave it code. It then went and wrote a whole lot of machine language that did the work. DAG visualizations are, this isn't a particularly interesting one of the better ways to try and understand what it is Spark is doing under the covers. This one's a little wide. I don't know if I can minimize that. Nope. But it gives you the walkthrough of how it broke the work up and sent it off to clusters and then got the clusters back to the control nodes and managed the partitions, bunch of stuff coming in under the covers that you can visualize in that DAG visual. You also have event timelines where you can talk about what was consuming most of the job, and we've got some additional metrics. Oh, we don't have any additionals in this one. Okay, so we'll go back and look at individual stages using the job ID. So we can go back here. In this case, we said, let's get all job IDs, but if we knew there's specific jobs we want to look at, we could then look at specific job views, right? Instead of all 4, we could look at 1, 2, 3, or 4, or any number that exists out there. Let's look at the playback feature. Sometimes you want to know what happened, and it recorded what happened as it was happening, but you weren't there to watch it. So if we hit playback, this runs that this job took 1 minute and 12 seconds. So we could hit play, and it says, oh, this is what happened. We went through 0 pretty quickly, then went to 1, then went to 2, and jumped to 3. And you can see the duration and what's happening here. When it's not quite so linear, it's very interesting if one of the stages is blocking other stages. Which stage is it that was the one that's blocking? And what is the relative amount of time in a story environment versus you can see it in the number of seconds and durations. But the graphical order of execution when you run play is just bright and obvious. And you can also move the slider forward, to a specific piece. And you can see that right here, we're in a big data read relative to the other data reads. And then we've got a data write that occurred in stage 2. These are also pausable. So if you got something you said, that's it right there, you can pause it, and then you can go take a closer look. So let's move it to stage 3 is done. So we could move it into the playback to a spot where 0, 1, and 2 are done, stage 3 isn't, and then look at those details. So in this case, we're watching progress, but if you know that you're more interested in the reads, or you know you're more interested in the writes, or more interested in the durations, you can change that view. So we did progress before. You saw the green when it completed. Let's move that to reads, and now we're going to watch the amount of data that's read. And you've got a standard deviation here for fast reads, slow reads, and then a visible pop-up of what's in the top and what's in the bottom of those read paths. And same things for writes. So it gives you a graphical way to replay it and to get at the bottom of what's fast, what's slow, and where you go when you want to do some tuning. That concludes the exercise 2 portion. So at this moment, I'm going to take a break. I'm going to flip over and see what our timer is left on the labs. 2 hours and 4 minutes. So halfway point. I'm going to suggest about a 5-minute break to go be human, and I'll come right back. Okay, let's move on to lesson 4, exercise 4 here. Sometimes the Power BI one takes a bit of fiddling to get to work, so I'd like to save that for last so we don't miss exercise 4 because we're busy trying to connect Power BI. So with that in mind, if you're going to the exercise 4 tab, the purpose of this argument or this exercise is to understand the high performance analysis with Synapse dedicated pools and some of the features from within the pool. So there's some SQL that they've put together for you, and we're going to walk through that. And we're going to discuss why some of these things are working. So if you go to, and these are all laid out in exercise 4. If you go to develop and then under SQL scripts and then to exercise 4, we're gonna look at analyze first, I believe. And we're going to try and look at some data sets first, and then we're going to look at the performance of this data set. So let's do the analyze first. So if you go to develop and then exercise 4, analyze, we'll get select customer key and some of the quantity from the fact sale. So we'll go and run this against the SQL pool 01. Your SQL pool 01 may have stopped. If it did, you'll need to go back to your SQL pool and restart it. If it's showing green up here, then it's probably still running and you're just fine. Generally speaking, as I mentioned, if you have a SQL pool and you're paying for it by the hour, you want to stop it when you're not using it or when there's no one active with it. It can actually be more cost effective to have an Azure SQL pool that you pause and start than a full-time database running all the time, whether you need it or not. So with this analyze transaction, we'll go ahead and run, and it's going to run. You'll get messages in the start time. And the challenge that you get in the task 1 is how do you make this data useful at a glance? Yes, you've got the data back, but what are you going to then do with it? So if you were to pull that data, you can then turn it into a chart. The chart here, again, isn't set up to be immediately valuable. What you could do is count, let's do a column chart. And let's do customer key and not a quantity. And we've got one value over here for customer key. So I'm not entirely sure what we've done here. Can you author an query that aggregate the total quantity of items purchased by the customer and then visualize the result of the chart, similar to the following? Some quantity by customer key by fact sales. So chart type would be column, category column, none for the legend. Series column, we have customer key. All right. Not entirely sure why we're not getting the graph that they recommended, but it may simply be that this is skewed so much that customer key 269 is at a scale with the rest. So let's see if we can. $269. Okay, let's try to see other values here. All right, not exactly what I had expected. So we'll leave that for Power BI perhaps. I think it's probably pretty rare that you're actually trying to do visualization straight in the Synapse Analytic pool, but you will need to know how to do performance tuning in these environments. So the task 2 is actually more interesting to me in that they've got some tables that are set up as slow tables and fast tables, and they've got some SQLs that are set up as fast and slow SQLs. And it's worth looking at how the structure of those tables influence whether they behave slow or fast in certain conditions. So we're going to go into the exercise 4 investigation and then run the select count from perf sales slow. And if you run this, we'll get the results in 0.1 seconds of 8,000 columns. So let me give the quantity there. And then let's go into fast. And we get the same number. Embarrassingly, fast was a little slower than slow, but let's run it a couple times just so you see that the same numbers and how much the average runtime on these is. So this was 1 second. We'll run it again. And this is again 0.1 seconds. And this is again 0.1 seconds. And this may be cached at this point. So it may be that we're just getting cached values that are nice and fast. Yep, I think it's what we got going on. 0.1 seconds. Yep. Well, could also be a large pool allocation. So we'll get that run back one more time just to confirm. Okay. So at the very least, we've confirmed that caching works, and we've confirmed that both the slow tables on the fact sales and the fast table on the fact sales have the same number of rows in them. We're going to do a select on line 3 here. 5 to 20 and get run, and we'll run that 3 to 5 times until the execution stabilizes, and that cold execution should take longer than the hot ones. Instructions say it should take 15-30 seconds to run. We'll see what happens. But in this case, we're joining the fact slow on the city dimension, so that we can get dimension information from the dim city country to put into distinct countries that go along with this fact table. So rather large join here, 83 million rows. So run it once. One thing to note is that in the SQL pool for Synapse, there is implicit massive parallelization in the background. It takes the database and shards it out into 60 copies or 60 different partitions. And each of those partitions go to different nodes that do their independent processing and then come back. So it's immediately highly scalable. And it manages all that under the seams for you. It also means if you want to do things like partition, you need to be aware it's doing some of that implicitly for you ahead of time. So we've got 26 seconds to get that query to execute, and a reasonable stack of results out there. So let's mark this at 26 seconds. And let's run it a couple more times, see if we can get it to stabilize at a specific runtime. All right, second time was 7 seconds. We're seeing the system warm up a little bit here. And a third time. And 7 seconds. So we seem to have kind of stabilized at 7 seconds is how long it takes to run this specific query, joining the dim city to the fact sales on the slow version of the table. All right, so we're going to jump down here to the fact sales fast table and run that. And again, we'll run it 3 times and see if we can get the execution to stabilize. All right, so we got to the bottom of this in 21 seconds, a little faster than 26 seconds. We'll get 2 more runs out of this and see if we can get it to standardize, stabilize. Okay, that's 3 seconds. And then we'll run it a third time and see if we stay at 3 seconds. Okay, and that one ran again in 3 seconds. I'm getting the times off the bottom corner down here. I'd like to get a number of results, but I'm not seeing those handy. I'm sure it's somewhere, I just don't see it at the moment. So the question becomes, if fact sales fast is 83 million rows and fact sales slow is 83 million rows, why, when you join to fact sales slow, does it take twice as long as it does when you join to fact sales fast? The same number of rows. And in order to dig on that a little deeper, we're going to go into the data pane and we're going to look at these tables. So we're looking at WWI perf fact sales fast and slow. Let's go to the data pane and take a look. So SQL pool, WW perf fact sales. Okay, WWI perf is the schema, and then fact sales fast, fact sales slow. So here's a hint. They're looking different in this icon over here, and that's part of what's going on. But at the surface level, if you look at the columns, they're going to have the same columns, right? If you're looking at indexing, they actually also have the same indexing. But let's look at what happens if we create the table. So a new SQL script, let's create, and we're going to see how the table was created. And in this case, fact sales slow has a clustered column store index on it. That's part of how it's able to get to 83 million records on that single column inside a couple seconds. But you'll notice the distribution was round robin. And then we'll look at fast so you can see the difference. So that's slow. If you run to the fast one, oops, we didn't want top 100 rows, we wanted to get one. All right, you'll notice that this one has a hash distribution on the customer key. So when you're working in Synapse SQL pools, as I mentioned, there's 60 databases out there that are supporting this one readable instance. When it shards out the data across these large tables and you distribute them, it can distribute them randomly in a round robin. That just means in the order that the records come in, it's going to be like you're shuffling cards out at a poker table. There's one for you, 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 and then you come back around the table in a circle. So it's almost completely random what data ends up in which database, which allows for parallelism, but it also means that work has to broadcast between the nodes because it can't count on the information being local to the nodes. In the case of the fast table, the hash distribution was based on the customer key. So in this case, we know that similar customers are on the same node. Ideally, if you had two tables that were distributed on the same hash key, all the local work could be done on the node and it doesn't have to broadcast that information out. And then it sends the results of that work back into the master controller. Now, the truth of the matter is you're not always going to join everything on the same key. So you'll have to find the one key that has the most value for you as the hash or the master partition key, and then use that as your hash key. And you may, in turn, discover what were we joining? We're joining on Dim City. So if Dim City had a customer key, unlikely cities have customers, or customers have cities, not cities have customers. You would want to distribute that in the same hash key wherever possible. So you find out what your master kind of key is. There's also a distribution option that says, this table is so small, I just want you to make a full copy on all 60 databases. I don't care, it's going to use some extra energy and effort. But now, if you were going to broadcast any information from the small table, you don't have to because it's all on that one local partition. So the distribution method that you put into your Synapse tables, especially large ones, has a large impact on your runtime. Your runtime has a large impact on your cost, not your storage, but your compute cost. So that's a quick primer on how you want to look at structuring your fact tables in Synapse so that you're purposefully distributing them on a useful hash value. Let's see. We talked about resource classes when we were in the other one, and there are some static ones in the system, and there's dynamic ones that use more or less memory. It's important to know that if you don't want someone to consume all the 100% of the resources, you need to put them in a group that prevents them from auto-expanding to use all available resources. If you do want someone to get the absolute fastest service at the cost of concurrency, then you can put them in these super large resource groups that allow them to consume, 70% of the resource allocation. If you want to divide your workloads and say, I'd like my ETL resource group to be isolated or independent from my analyst workload or my underwriter workload or my cube refresh workload, you can segregate the workloads by using these resource classes. And in a pinch, if something isn't running fast enough and you've looked at all the other tunings, you might want to see, did they get stuck in a small resource class? And it's really not that their code is inefficient. They're just been given a very small fraction, maybe only 3% of the overall resources in which to run their execution. And maybe their execution warrants being bumped up to larger resource class. Maybe it doesn't. Maybe they are, the people that can wait and go get a cup of coffee while their job finishes. We used to joke about this being the CTO button or the CDO button, where if your chief data officer said it's not running fast enough, you just push them into the larger resource category and they get more resource that runs faster. But that can have an impact on everybody underneath them in these other groups. So it was just a tongue-in-cheek joke. Let's see, let me bring up broadcast joins real quick.
Everything okay?
So within Azure Synapse Analytics, you can optimize this distribution. We just talked about it for the dedicated SQL pools and optimize that broadcast data movement. This is where when you create the data, you want to be careful about broadcasting move operations, specifically for small tables. You can afford to just copy. And there's an opportunity to get some explain with recommendations that tell you what you should be doing or what it sees would be more effective. So the specific string that I was thinking of looking for before is the distribution replicate. So you wouldn't want to do this for a large table, it'd be very expensive, but for a small table, maybe it's a lookup table or a little dimension table, certainly not a degenerate dimension table. You could set the distribution to replicate, and that could save you quite a bit of broadcast joins on information that didn't need to be in more than one places. Now, I don't think they did that on our example. We can go take a look at the dimension because they wanted the slow table to run slow. If you had to replicate the slow table and round robin, might not run much slower than the other because it knows the join is local. If you get your hashes lined up, you can avoid that shuffle move that we talked about since that large data exists. If you like, I can post this link out into the session so you get a better look at what's going on under the covers in Synapse. And then here's the one for the resource management. All right, I'm curious because I'm a curious person. What they did with the city table. Sounds like a dim city table just for giggles. If we're in data and we're in back dim city, we could do a create on this one as well. Yeah, and this one is just distribution replicated. So this is pushed out to each one of the nodes. It just so happens that customers are likely to be in the same city. So when they're in the same city, it's a closer node and a better read on that big fact hash table. So I would, generally speaking, rule of thumb, never have your fact table as a round robin and pick the best hash possible for its performance based on the majority of the joins and access paths, and within the DIMs, especially the smaller DIMs, I would go ahead and get those on a distribution replicate. So I'll stop here for a moment. I don't think there's anything else on the task activity for this last exercise that we did. We can back up and do Power BI now because I think there's plenty of time left on the labs. I found the performance of Synapse to be highly tunable and configurable if you're doing certain things, and certainly getting 83 million records processed in 3 seconds is a pretty nice response, but it comes at a cost, and you want to be careful that you don't over provision the solution when it might be just a simple case of managing resource classes or managing distributions on your tables. So I'll pause for a moment and see if any questions pop up. Either unmute and ask them vocal, or you're welcome to type them into the chat. And then I'll queue up the next the Power BI exercise. I believe it's exercise 3. All right, we're going to go ahead and kick into exercise 3 now, where we're doing Power BI integration in Synapse. And the goal of the exercise is to create a Power BI data set in Synapse and then be able to create a Power BI report in Synapse. You can also use the traditional tools like Power BI Desktop and connect to Synapse. There's some integrations within Synapse that encapsulate and protect you from some of the network effects of dealing with large data sets and trying to pull them down into your desktop, and also the latency involved in doing direct queries across the wide area network as opposed to inside of Azure. So we'll try and work through this. This lab has had connectivity issues in the past, so we'll see how well it's working today. And sometimes we can surmount them and get through them, other times not so much. The instructions advise you to make sure that you've got a good grip on your unique IDs and your ODL user string. That'll come in important in a couple steps. But we're going to go into the create Power BI dataset in Synapse via the develop tool, and I'll screen share and walk that through. So as we go to the develop tool, that develop hub, I'm going to close a bunch of these. I don't think these are adding value right now. There we go. We've got the data flows already done. I'll leave that there just because the string is sometimes useful. And we don't need that. So within develop, under Power BI, we then have Power BI Workspace. Okay, and then we got Power BI data sets. From within Power BI data sets, we're going to then click New Power BI data set. And it's going to want to go through some of the PBIDS Power BI work and get that run locally. So let me see if I can get that running on my local desktop, because I really don't like using the VM. If you don't have Power BI installed locally and you want to run this, you're certainly welcome to do that all from here, this reduced pane. Why don't I try it here? That would probably be easier. We'll just see if we run out of real estate. Go into Azure portal. Okay, I've got in the sales portal. Okay, we'll get back into that Synapse workspace so we can follow this officially correctly. Okay, open Synapse Studio. All right, and we're going to go to develop, if I remember correctly, Power BI Workspace, Power BI datasets, and new Power BI dataset. All right, so from here, I'm going to hit that start button. And then we're going to SQL Pool 01. Remember, the on-demand was the one that was the shared resource that you don't have to start, but is a shared multi-tenant tool. Your data doesn't cross tenants, but it's not dedicated to you. And then SQL Pool is dedicated to you, and you get to decide how much capacity. This is by terabyte. This is by DW by hour. So we're going to continue this. And this is going to download a PBIDS to the local drive. Okay. So that's the PBIDS file. And we can then open that file to launch Power BI Desktop and continue this. So if you have your own copy of Power BI, you're welcome to do this in Azure portal outside the VM. If you don't have Power BI Desktop installed, it's probably going to be challenging to get installed and configured and hooked up to the user before we run out of lab time. So. So you see it's establishing a connection to that workspace with the unique ID that you already have, because that was part of the PBIDS file. It's going to ask you to log on here, hopefully, after it connects. All right, so from here, if you had a Windows account login set up, you'd use a Windows account. If you had a database account, you'd log in with a SQL user, SQL password. In this case, it's looking for the Microsoft account. And then we're going to sign in, and we're going to have to sign in as, you know, our identity. So we can go back to the environment details and pick up the user. I think the last time we did this, they're working on single sign-in, and that's why it was a little iffy. Okay, so we're currently signed in. We've picked a workspace. We go back to the lab guide. We're going to go to connect button. We can go to something like fact sales and get a preview. So this is the data from that fact sales table in the SQL pool. If we had to do significant transformations, we could do it here, although it feels a little silly to ask Power BI to do transformations that Synapse could have done much, much better. We're going to load this, and it should pop up with import versus direct query. Okay, so import means we're going to import it to the local in-memory model on the VM and suck down 83 million rows worth of data. Direct query means we're going to leave the data where it is on Synapse, and we're just going to store a meta copy of the data on Power BI, and when Power BI wants data from the Synapse SQL instance, it's going to write a query and go fetch it from Synapse and then return the data. So direct query is non-local storage. Import is local storage to Power BI. Eventually the local storage moves up, but because of the scale, we probably want to use direct query against Synapse unless it's a really reasonably small model. So direct query, and then we're going to go OK. All right, so it looks like we've gone there, and from file, now we can publish this. Publish, change the UI a little bit. Publish to Power BI. Okay, go to save the file. Enter my email address. Okay, that's my mail address again. Not sure if it's done publishing. We'll try publish one more time, perhaps. Okay, so I think I may have picked my workspace, and that may be the reason why I'm not been successful. So we're going to close this file again, if I can get it to close. Oops. And we're going to try to open the PBIT and try this again. This is, again, where it gets stuck occasionally. Downloads. And if not, I can try it off the VM and see if that works better again as well. I'm not certain I have the right version of Power BI installed on my personal desktop. Okay. So back up to here, connecting. It's going to ask us to sign in. Oh, I remembered. We do fax sales. We're going to load. We're going to pick direct query. Okay, we're going to go to the file menu and select publish, publish Power BI. We could save, oops, I should have used maybe the fact sales name. That could be it. File, published Power BI. Sure, I can save. Do WI fact sales. Back to the email address. This time we'll try to be more patient. Maybe the VM's not as beefy as it could be. Oh, here we go. Sign on. And it's going to want my account. There we go. And now what's my password? All right, and here's where I probably picked the wrong workspace last time. We should be picking the Power BI workspace with the unique number in it, the one it called for right there, and then hit select. This is how we're getting it. Power BI on the back end uses the same tabular model engine as does Analysis Services, the in-memory DAX tabular version. Synapse has embedded within it Azure Analysis Services as an engine, and it is that service that's receiving the definition of this tabular cube, and we're putting it in the Synapse engine by putting the workspace instead of the generic Power BI engine by putting it in the My Workspace. So select that, publishing. We should get published. Success, got it, awesome. So now we can return to the browser and close and refresh, and that new data set should still be open. Okay, so got it. Let's bring this one down. Yep, minimize, minimize. Back to here, back to there. There we go. Oh, close and refresh this. And within these data sets, we've got WWI fact sales, the one we just published to that space. So we're going to create a Power BI report in Synapse from within there. So delete, obviously, we can just undo what we did to publish, or we can then create a new Power BI report. As I mentioned, there might be reasons why you want to create the report in here. This is where the real estate gets just silly. Let me see if I can swap out to the other browser and get a better real estate experience for you. Okay. All right, so we're out of the VM. I'm just going into a private browser. Now we have a reasonable real estate to work with to put this together for you. Let me catch up to where we were. So we started a new Power BI report. In this case, we're going to get this designer tab open. If you're not familiar with Power BI, here in visualizations, you can choose from here fields that go into the selection criteria. If you don't see data fields under fields, follow the steps to fix below. Navigate to Power BI Dawn, a new browser, select sign in, use credentials, select workspaces. Okay, so I'm going to go through and fix task 2, step 2, and see if we can get the Power BI workspace correctly attached. So all right, so from within here, I'm going to select workspaces on the left. I'm going to go to the workspace that they gave us. I'm going to go to settings. Edit credentials, but the UI is not what they've got set up. All right, so settings. Source credentials. Okay, so I had to get there a different way. Your data source can't be refreshed because the credentials are invalid. Please update credentials and try again. So we'll need to edit the credentials. And in this case, authentication, it's going to be OAuth. And I'll let that be a sign in. Okay, so that should have fixed the ability to see these fields. So I'll hit refresh here. And there are the fields. But so the reason we couldn't see them is simply that we hadn't set credentials for the pass-through on the direct query in Synapse. So having fixed that, we are now through to step 7 from task 2 within exercise 3. So within the Power BI Designer, we're going to do line and clustered chart. And from the line and clustered chart, we're going to drag the salesperson key into the shared access. And it's just a little hard to see. Salesperson key goes into shared access. And we're going to do total excluding tax into the column values. And then we're going to do profit into the line values. we resize this clustered chart and fit the area, and the results look much like step 9 says they should. We're going to add some filters to select greater than, leave, is it 5 commas would help, 50 million, and then we're going to apply some filters. So profit is show is greater than, and we do 50,000,000, if I've got all the zeros right, and we're going to apply this filter. Okay, direct query. It took a second to go run the query and come back with the results, and we have the visualization change based on the filter. We can narrow down the results where the total profit is greater than 50 million, and we're pushing down all that filter to the SQL pool, and we can do a new query based on those executions. So we've let the SQL engine do the work rather than importing into Power BI and making Power BI do the work. It's much more efficient against the big data. It does require that your Spark cluster, your Spark pool is up and running. So from here, we're going to file menu in the designer and do a save as, file, save as. Let's say key sales by person. Save this. And now the report is available to authorized users within the Synapse Studio and the Power BI workspace. So we can view that SQL query if we want to. Remember how I mentioned this was actually running on Synapse behind the background. If, again, much more powerful than what Power BI could do by itself. We want to go look at what happened. We can go to the Monitor tab. And we can select SQL requests in the left menu, and then select SQL pool 01 up here. And then we've got all these QIDs, and we can also look at these ODL users, right? So the pass-through on the SQL was the ODL user pass-through. Let's take a look if we can get into one of these. Select top. This looks like a good one. I was hoping for another UI. Let's go back. Okay, so if we hit the more, we get a request content pane that pops up, and we can see where it ran a select statement, and we can also see that it was doing a sum of the profit, right? If you remember the Power BI, we were summation on the profit with a group by the sales product key. So you can see the result of that query. And then at the very bottom, we've got a coalesce that's based on a value greater than this 50 million, the 50 with the exponential 7 scientific notation. So you can go back and look at the queries that were run against Power BI. If someone's saying something specifically slow, this might be an opportunity to look at your round robining, your hashing, your cluster column indexes, your distributions, your resource groups, and look at ways to structure tune against the data request itself. But in any event, you can get all the way down to the execution of the direct queries within the Synapse pool and see what it is Power BI was doing and see if there are opportunities to make that a little faster, or recommend why that may not be the query that your user really wants to run. So that actually gets us to the bottom of the Power BI exercise 3. Having gotten all the way into the content of the SQL request that will run. Let me see how much time we have left on the cluster. So we've got 1 hour and 4 minutes left on my timer. Some of you will have started a half hour to me, so we actually made good time on the labs. There is a 5th lab, data science with Azure Synapse Spark. I haven't been able to get this to run to completion yet. The Onyx Apache Spark interface works. We've used it outside of the labs, but I don't think they've got the syntax on the labs perfect yet, and the connective tissues set up, but it is a good read. If you want to read that, you're also welcome to use this hour to kick the tires on Synapse. Let's make sure we open the mic for a moment. I also know that Lindsay sent out a note based on a survey. I'm going to repaste that survey into the message commentary. And if you have an opportunity to follow the link and fill the survey, I would really appreciate it. The more people fill these surveys out, the more of these sessions we can continue to give. When we don't get feedback, often our management says, is there a reason to keep doing these? So by filling out the feedback, you're helping us keep this program alive for future sessions, not only Analytics in a Day, but other initiatives. I'll open the floor to questions. You can paste them in the message, you can put them in voice, we can try to explore something, or you can have an hour of Azure Synapse to kick the tires and poke around in some other areas. Okay, with no new chats. Again, Lindsay mentioned if you fill out the forms and give her your mail address, she'll know where to send the PDFs of those slides. If you're interested, she can also forward some of the links I've posted before about the GitHub repositories that have the text of the exercises to include not only the pictures, but the code snippets that were in use. The GitHub has a environment setup tab where it's a bit expensive and tedious to set the environment up. It's much easier to use the ones that have been set for you, but all the content for the setup is in there should you wish to set up your own advanced analytics in a day. And appreciate your attendance. I hope you learned something. I hope this is interesting. As I mentioned, I'll be on for a couple more minutes in case anyone has questions. We can dig in that direction. If everyone's heads down and just enjoying their hands-on lab time, I'm also happy to let you go enjoy the last hour without having to listen to me. I'm certain after 3 hours, 4 include slides, you've had enough by now. Thought we might have a message coming in. I saw some typing, but it didn't show up. Oh, typing's back. All right, we'll hold on a while longer. Bethel, thanks for the comment. I'm glad that this increased your scope and your knowledge base. This field is an exciting field. We're seeing a lot of movement in the modern data estate projects. We're still seeing project work in the traditional relational databases, but as more and more companies are getting into big data and getting ready for data science, and exploring how they can leverage data lakes specifically to load everything and then figure out what it is they want to do with it. A lot of movement in the space, a lot of demand for people that have skills in Spark, have skills in Python, have skills in SQL, have skills in data lake files, and can manage pipelines and the movement of data. Just really exciting to see companies begin to transform their vision from data is a liability and something that they must deal with to something that can drive value and that they want to deal with. So just really neat to see that occurring, and a lot of big opportunities. If you've seen, you can manage really large amounts of data with a couple button clicks and an Azure subscription at this point. So Microsoft's done a really good job of wrapping it all into one package, one unified platform, so you don't have to go to 2 or 3 or 4 or 5 or 6 or 10 different places. You can access almost all of it from that one piece. So pretty exciting. All right, if there are no other questions, I'm going to go ahead and drop off this call, but Lindsay certainly has my information. If for any reason you had some more questions you wanted to route to me, she can manage that process. She can also get you in touch with people in our customer success group about DPI 30. This is one of the products that we'll use for the DPI 30 process as we land data into your environment and start making it useful. And she's got the survey there. Looks like Lindsay's got something typing. Super. And it looks like we're going to have a link to the lab recording if you wanted to replay me fumbling through how to connect Power BI to Synapse. But I'll get it better the next time. All right. With that, thank you for attending. I hope you had a great day so far, whether it's morning, evening, or night for you, and enjoy the 1 hour left remaining on your labs. The lab administrator will tear these down when the timer goes out. So if you have any interest in poking around and using some Azure spend, thanks to Microsoft, now is the right time to go do that. So thank you, and we'll see you guys later.